The next type of display is called a dot plot. Again, another quick way to create a histogram without having to tally the data. So this is the same set of data, the number of arrivals at Wendy's. We're going to put frequency along the vertical, and we're going to put the number of arrivals along the horizontal, starting with 1. The values will be between the marks because this is discrete data. And what you're going to do is, as you see each number, so when I see 7, I'm going to put a big dot filling in that spot for 7. When I see 6, I'm going to put a big dot filling in the space for 6. When I see 6 again, I'm going to stack another dot on top. When I see 6 again, I'm going to stack another dot on top. When I see 4, and you want to make your dots about the same size, again, as neat as you can be so you can really see the data. And we'll just keep putting dots. Sticker dots, if you guys are familiar with what sticker dots are, a lot of companies use sticker dots to kind of track their data throughout the day. So every time you see one occurring, you just throw a dot on there to represent that count. So it's kind of like tallying your data. But if you make these dots, then again, you're kind of building yourself a histogram without having to make a frequency distribution, without having to tally the data. So it's just another way to display numerical data in what we call a dot plot. You can see the finished product in your book on page 83. There's another type of frequency, or not frequency, yeah, it's kind of, no, it's not really frequency. It's a different way to display what we call time series plots. It's a graph of quantitative data over time. So what that is that time is along the axis and the values are along the horizontal. So at this time, this was the value. At that time, this was the value. At this time, this was the value. They do this with gas prices along each day. In a time series plot, you kind of connect the dots to see trends over time. And there's some examples of that in your textbook as well. We don't really do time series plots in this class, but they are helpful if we're trying to measure something over days or months or weeks or hours or years, trying to see those trends. All right, the last part of section 2.2 is about different shapes of distributions. And this is a very important concept that we're going to see throughout the rest of the course. So histograms can take on lots of different shapes. The first shape is called uniform. And that's when all the frequencies or relative frequencies are roughly the same. And you kind of have a little rectangle box display. And we'll study these more in chapter 7, uniform. The most common kind we're going to see trend up in the middle and back down on the edge. So they kind of taper down on the lower and the higher, and the majority of the data is in the middle. This is called bell-shaped. We're going to study that a lot in chapter 3. We're going to see that's a lot, bell-shaped, and then again in chapter 7, 8, 9, and 10. So bell-shaped is a very common shape for displaying data. Then we have skewed to the right. That's when your majority of the data is lower and it trails off to the right. So we call it skewed right. And we also have skewed left, where the majority of the data is at the top, at the front, the higher numbers, and it trails off down into the lower numbers. So this is called a tail. You'll hear me refer to this as a tail. The tail is where the numbers kind of trail off. And so skewed right, the tail goes to the right. Skewed left, the tail goes to the left. So if you think about an animal, the majority of their body's here, and then their tail's a small part of their body. Majority of their body's here, and the tail's the small part. So if the tail points right, it's skewed right. If the tail points left, it's skewed left. So throughout your homework, they'll have you make a display and then talk about the shape of the display. We can get that from histograms. We can get that from stem and leaf plots as well, or dot plots. So those are the 4 shapes we're going to study. Uniform we'll look at a little bit. Bell-shaped is the most common. This course does not get into very many skewed situations. It's a different way to calculate things that we do not study in this course. All right, finally, the last part of Chapter 2 is graphical misrepresentations of data. This is a topic that is very interesting, but it's not a main topic of our course. But data can be misrepresented lots of different ways. So this is just a few examples of how data can be misrepresented. So it says a home security company's summer campaign had the slogan, "When you leave for vacation, burglars leave for work." According to the FBI, roughly 18% of home burglaries in 2009 occurred during the peak vacation months of July and August. The advertisement contains the graph shown in Figure 19, which is this one. Explain what is wrong with the graphic. So we have July and August here, all the other months here. So the first thing is that this is not evenly distributed. We talked about having even spacing between the different categories, and so they didn't evenly space these. Another thing is that percentages generally add to 100%. So those two numbers don't add up to 100%. So it's very confusing where 8.2 came from and where 18% came from. It just doesn't make any sense. So again, the sum of the percentages, the relative frequencies over all 12 months should be 1. But it's not 1. It's clear that the bar for the other months must represent an average percent, while the bar for July and August represents the combined percentages. So they took an average here, and they took a sum here. So the numbers are accurate, but they're misrepresented. So if you look at the chart at the bottom of the page, notice they've spaced out all the months, January through December, and each month has its corresponding percentages. So if you look, just glancing at this, it looks more uniform. The graphic up here makes it look like July and August were double the other months. But if you look here, they're pretty even. February is a little lower. It's a shorter month and it's very cold. July and August are a little higher, but those are also longer months and the weather's better. So this is a more accurate representation of the burglaries, but the company trying to sell home alarms would use this graphic to misrepresent the data. Here's another example of a misrepresentation. These two charts represent the same data, but I want you to kind of look at the difference. Let's see if you can see the difference for yourself. I think it's different opinions about a court case. Democrats, Republicans, and Independents. Upon first glance, it looks like the Democrats feel very differently from the other two parties. It looks like there's a huge gap between those two bars. But if you notice, our percentages are kind of zoomed in between the two, between 53 and 62. If we zoom back out and start at 0 like we should, the bars are a little bit more even. So 54% is not that different from 62%, but they made it look a lot different in the first display. So this display is misrepresented. So they kind of zoomed in to make it look very different, and this is a more appropriate display of the data. Let's look at that one more time. Which one of the following best represents the data? So this is average SAT math scores over time. So we talked about when we're trying to study something over time, instead of making a bar for each year, it makes more sense to make a time series plot. So here they kind of zoomed in on the SAT scores. Here they kind of zoomed out, so they kind of all look uniform. Here they look a lot different because they really zoomed in. But a time series plot shows you the trend over time without seeing all the individual bars. So a time series plot is the best way to display data that's being measured over time. Again, we don't focus on that too much in this course, but here's an example of when it would be appropriate. All right, that is it for Chapter 2. The homework's a little shorter for Chapter 2. It's a short chapter, but it's really interesting, all the different ways we can display data.